Okay, today's session we are going to discuss the visualizing group data, a mastering guide to statistical analysis. So in the previous session we are talking about how we are going to uh, group the data set. It's mean making classes, what are the steps. So we can recall. First we have to find the range, and then we have to decide how many classes we have to keep, and then we have to decide the width, class width, and then we plot there. We make the classes, and we assign the observation the particular classes. So that where we have identified what is the class boundary and theoretical limit and class mark and open class, closed class. So we have discussed many things. And the basic uh, level of visualizing the data, group data, is histogram, right? Histogram. And we discussed a very few example of histograms. Plus we are going to discuss here polygons and ogives for data, for the group data, right? And so from raw numbers to strategic pattern. Here this is a raw data form. This is raw data. It has noise mean it has some of the outliers, and by looking at this raw data it's very hard to find to one conclusion. So we couldn't find any pattern, right? So is noise, right? We couldn't recognize anything in the raw form, and we transform this noise into signal mean meaningful insights, make the raw data into meaningful insights. Here identify majorities, so which number occurs many times. So in the histogram we can identify mode very quickly, how the data is distributed across the means, and the data is spread throughout the x variables. So we are the bulk of our workforce concerned. So if we take it's a workforce age, employees age, and you collect the employees age, and by looking we put the ages like this, you note the ages like this. It's very hard to find what is the mod mean which age group occurs many, right? So therefore we have to make some of the visualization form and analyze the trend. How does performance shift across segments? So if we have different product sets, A product, B product, C product, and you want to measure which product gives more performance, so that the visualization may help you. At least you have to have a table and set benchmarks. What defines the top of percentile of the performance? Which products are performs at the best? The foundation, the frequency distribution, we have discussed this thing, and here the distribution is given. The age distribution is given in this table form. This age distribution is of the factory workers. It's a factory workers. Here the classes we have classes 20 to 24, like that. It's given, and by looking at we can realize that the class size is 5. Class size is 5, and the frequency in this class there are 10 employees, and this age range there are 16 employees likewise. So when we look at this, which is most popular age group, right? In here 48, this age group got highest, right? Highest age group 35 to 39. The frequency distribution organizes individual data points into classes and creating a structured input required for all visual analysis tools. So this histogram is the foundation. for making visualization, right? So first we convert the raw data into group data. It's mean frequency distribution. So based on this, we will go forward. The histogram visualizing the shape of the data, right? Here, this data set is converted into a histogram. When you look at here, the frequency, that frequency is located here. What is frequency? Number of workers. And the age group. Here, how many groups? 1, 2, 3, 4, 5, 6, 7. There are 7 age group. Here you can find the 7. 1, 2, 3, 4, 5, 6, 7. There are 7 age groups. And we start drawing a histogram. Right. You see here, what's the class boundary? The class boundary of each classes. The lower boundary of this class is 19.5 and the upper boundary of the class 24.5. Likewise, second class 24.5 and 29.5. Likewise, we can define the class boundaries. So here when we draw the histogram, we have to take the class boundary at the first class boundary 19.5 into 24.5, right? Here this class, how many frequency? It's 10. So here we have to find the 10 and draw, right? 10. Second class, 16. Third class, 22. Next, 48. Likewise, we we find the top area, top location, and we draw rectangles. Right, so this is the histogram. Right now, you can realize this is the histogram. Here, it's very easy now to locate which age group is most frequent. Here, the tallest, here the tallest one representing the rectangle. Tallest rectangle is the mode instantly visible. Right, by looking at this graph, we can quickly trace which is uh, mode. The bulk of the workforce, many of the workforce is age between 39 to 39 to 35 to 39 with the taper towards retirements. Right, now we learned what is histogram, how do we draw histogram, right? So we did, everybody can uh, draw histogram, right? Second, we move to polygon, right? Frequency, polygon, frequency, polygon, the track in the tent, right? Here you already drawn this histogram. To draw this, first you have to draw a histogram, right? And then you have to identify the mid locations, midpoint. So what's the midpoint here? 22 point or something, 22. Here midpoint 27 or something, and here midpoint, right? You have to find the midpoint, right? Midpoint. And connect these points using your ruler. So the point has lot of, right, plus, right, in addition. So the line should connect to the x-axis, so that when we draw this we have to add one more classes at the bottom, at the beginning, and at the last, so that we can connect here. So here to add one more class at last, and one more class at the beginning. Right, here you see this is 19.5, this is 24.5, and this is 29.5, this is 34.5, like that. Oh, here this is our histogram, previous histogram, and here we find the midpoints, mid values here, mid value. We find the mid value, and we connect all mid values here. Here 19, I mean the 14, right? 14.5 and 59.5. So they have added one more class, right? Here also one more class. So how many classes? Originally we have 7 classes, and we need 2 classes at the beginning and at the last. Here 1, 2, 3, 4, 5, 6, 7, 8, 9 classes. There are 9 classes. So you connect this point. So here 0, it should be the connect from 0. It also end up with 0. And you connect all the midpoints of the histogram. And then it's called frequency polygon. So why use this? Unlike blocky histogram, so this is a block. This is another block. This is another block. The polygon minimizes the visual clutter, making it the preferred tool for comparing different groups. Right. So when we have histogram, it's very hard to compare. Right. Compare with another distribution. For example, product A and product B, or factory A workers, factory B workers. So how we can compare those two factory employees age distribution, right? So here when we draw the line, so this is maybe this line representing group A, or not group actually, product A, and we can draw another line like this. Sometime it may like this is product B, and we can draw one more, right? One more like this. So this is product C maybe, or factory C. So that in a particular, right, in a particular histogram, in a particular polygon, we can see the distribution. We can compare the distribution of different workforces and different lines. Right. Here, the next histogram, here, the next visual is a smooth frequency curve. Here already we have discussed histogram and then polygon. Now smooth curve. Right. Smooth curve is, it's not a new thing. Right. In the same graph, what we do is, the earlier we connect the midpoints using a ruler. Using ruler we connect this. So we find the locations, midpoints, and using the ruler, we connect them. But here, smooth frequency curve mean, right? Here we connect them by your hand, right? Like this, right? So curve using curves, so that it's easy, right? It is easy. Uh, so here, frequency smooth curve, right? Now they are connecting using the point, right? I can show you in the PDF, right here. You can see this. The frequency, right? The curves, the points are connected. Frequency prediction curves are connected here. So this is a midpoint actually. It was like this. It was like this. Now we connect these points. You see, first we plot the points and we connect the points. Then we connect without the breaking line, right? So we can draw a frequency, smooth frequency curve. Smooth frequency curve. The interesting thing is the area of histogram should be equal to frequency polygon and equal to area under the curve. So what does it mean is here in the histogram, right? So you can identify, we can measure the area, right? For this rectangle here 5 into 10. So 50. This area is 50. And here 5 into 16. So this area. And 22 into 5. And 48 into 5. So when you add all things, right? So the area of this histogram should be equal to area of the polygon. Area of the polygon. So the histogram area, this area should equal to this area. And also the smooth area, the smooth frequency curve, area under the curve also should equal to the frequency polygon. That's why it's noted in a graphical form. Area of histogram equal to area of polygon and area under the curve. So this area and this area should be equal under the curve. The curve represents the general population model. Smooth out specific sample irregularities to aid forecasting. Right. So uh, this may be useful for many applications. We will discuss in the forthcoming classes. Right. To shift to cumulative analysis. Cumulative mean what? We are in the total. Right. We take the total frequency up to a particular class. Yeah, we draw the histogram, frequency polygon, smooth frequency curve, everything. Right? They are standard frequency. We are not add together. We consider only a particular class frequency. How many groups in the, how many members, how many in this group. So that's what we discussed. But now we move to cumulative frequency, concept cumulative frequency. So we up to class 1, how many employees? Up to the class 2, up to how many class? How many? For example, below 24.5 years, how many employees? Below 29.5, how many employees? So it covers this as well. Cumulative frequency, how many are above or below the threshold? So this is threshold up to this point, up to this point, or up to this point. So it collect everything. Managers often need to answer capacity or performance questions such as how many employees are under 30 or how many sales reps sold more than 700 units. So this kind of questions may need required, right? The standard graph doesn't answer this quickly, right? So we need cumulative frequency tool. So if anybody asks how many employees up to age 24, how many employees up to 32, right? So we have to count manually. It's take a little time. But here we can introduce a new method. Uh, Ogives. The new term is Ogive. So by using Ogive, we can identify we can use the Ogive for many applications. It will give a lot of insights. Before that, we have to construct a cumulative frequency distribution table, right? There are two different types of cumulative frequency. One is less, right? Cumulative less and cumulative more. So what the difference is what here the less than 19.5. How many employees less than 19.5? Nobody. Right? When you see, look at this data set, you see uh, less than 19.5. Less than 19.5. How many employees less than 19.5? Here, this is lower boundary now, 19.5. But we know the employees, the age between 20 to 24 is 10. This means less than, right? Less than 19.5, nobody, right? But less than 24.5, less than 24.5 is 10 employees, right? Less than 24.5, 10 employees. Now, next, less than 29.5, less than, below 29.5 is 16 plus 10, because the less than 29 point include this group as well. So that 10 into 16, 26. Here, 26. And here, less than 34.5. Already we have 26 and plus 22 and 48. 48 less than 34.5. Likewise, less than 39.5, less than 44.5. Like this, we can get the accumulation. So there are 160 employees. 160 employees. That is called cumulative less than upper boundary of each class. Upper boundary of each class less than. So that is one thing. Another method, more, right? More than 19.5. Right here, when you look at this table, more than 19.5. So in the less cumulative, we take the upper boundary, less than 24.5, less than 29.5, less than 34.5, like that. But here, for more, right, more, we consider this lower boundary of the class. So here we can write above 19.5. How many employees above 19.5 age? We consider all, right? All employees are above 19.5. So how many of them? 160. 160. And above 24.5. Above 24.5. So we exclude this. So we know that already 160 minus 10. This group we cannot include that group. So therefore 150. And above 29.5 or more than 29.5, right? We consider this range. Or 160 minus 26, 134. Likewise, more than 34.5, right? So we have to consider this group. That is 112, 64, 28, 8. Here more than 50. So the 49.5 is 8, and more than 54.5, more than 54.5, nobody. So 0. So very careful, right? The less, cumulative less, start from 0 and end up with the top, the total. And the cumulative, the more, right? There are two types. More, start from the total and end up with 0, right? Right now we have the table. We have a cumulative frequency distribution table. Using this table, we can draw a diagram. So that is called Ogive, right? It's called Ogive. Now we work on Ogive accumulation. Accumulation means the less cumulative frequency, less. Less mean this chart. Right. Now we have to start from the lower boundary of the first class. So that start from 19.5, and we have to use the graph sheet, and we have to equally divide, and it should end up with the last class, upper boundary of the last class, less than 54.5, right? So we take the last range, 54.5. Right, so we have to make it very clear and neat. So this is x-axis, class boundaries, not mid-class. Very careful. We are considering class boundaries and frequency, cumulative frequency, not just frequency. Here, cumulative frequency. And the first here, less than 19.50, less than 24.5, 10. Right, this is 10. And less than 29.5, less than 24.5, 10. Less than 29.5, 26. This is 26. And less than 34.5, less than 34.5, 48. This is 48. And less than 39.5, 96, 96, and less than 44.5 at this point, 132, and less than 49.5 at this point, 152, and less than 54.5, 160. So, right, we have to stop here, 160, right, 160. Now we can see a graph like this. Connect all the points and draw a graph. This line is called Ogive. Right? Ogive. So the graph cumulative frequency distribution is called Ogive. It allows managers to graphically determine median and percentiles. How we can decide the median? So we know median means the middle value, right? Middle value. So n 160 and total number of observation is 2. So the middle value is 8, 80th. So 80th item. So here 80. And then we connect this line. Yes, here it tangent, it touch at this point. And take down this. Right. This point is called the median. Median. And the quartile was Q1. How we find Q1? We know that 160 observation, 4 into 1 equal 40. 40th observation, this is 40. 40th observation, this. And getting down here, this is Q1. And that's Q3. Q3, 160 divided by 4 into 3. Then 120. So what is 120th item? Right? And getting down. So this point will be the Q3. Right? So this way we can find a lot of things. Right? And also we can get more insight than this. If anybody asks the question, the managers want to know how many employees are below uh, below 30 years old. How many employees below 30 years old? Here we key point 30. How many employees? Right. Right. And right. And there are maybe 22 employees are less than 30 years old. And how many employees are 50 years old? Less than 50 years old. How many employees are less than 50 years old? Here we can find 50 and we track the line. Right, we touch here and yes. And when we look at this point, it's called what? The number of employees less than 50 years old. So this is how we can get more and more data, more and more insights. Right. One question is given. Before that, I can show the correct diagram, correct form of the diagram. Okay. This is the question, actually. This is a question. The following frequency distribution shows the distance is traveled by 66 sales representative. So the total sales representative is 66. There are 66 sales representatives of firm during the given period. Travel distance, right? Travel distance. Sales rep mostly travel, no, they travel across the cities. And travels distance 300 to 399. There are three sales rep traveled, and the kilometer 400 to 500. It's mean 400 to 499 kilometers. How many? Nine sales rep traveled this amount of this length of kilometers traveled, and 500 to 599 there are 15 travels, 15 sales rep traveled. So that data is given. The question is construct ogive less. So less than 299, right? And then less than 399.5, less than 499.5, less than 599.5. In that way, we have to construct. So this is the question, right? Here there are sales rep. Each sales rep are traveled for the city. Objective, evaluating 66 sales representative on a distance traveled. Here this kilometers given and sales rep. Here how many? Less than 399, 3. Less than 499, 3 plus 9, 12. And less than 599, 9 plus 15, 24. And less than 699, 7 and 47. And less than 799, 58. And less than 899 is 66. Right? There are some differences, calculation differences. Let's see. Okay. Okay. 'So this is the Ogives distribution. So we did some mistakes. We will find where it is. Let's see here. Zero, that less than 29.990. 3 to 12, 27 actually. We made mistake here. Yes, we made mistake here. It should be 27. 9 plus 15. Actually, we put the wrongly. We put here 15. Actually, it's 12 and 27. Right? Let's see. Wait. Should be like this. Here 0 3, right? 0 plus 3 3 and 9. 3 plus 9 12 and 12 plus 15 27. 27 plus 23 is 50. 50 plus 11 61. 61 plus 5 is 66, right? So we made mistake here, right? We made mistake. I'm sorry. Here 0 3 3 plus 9 12, right? 12 and 12 plus 15 is 27. 27 plus 23 50. 50 plus 11 61. 61 plus 5 66, right? This is the cumulative frequency less. And by using the data, right, we can draw Ogive. We can draw Ogive. So less than 299, nobody here. Therefore, we put 0. And then next class, less than 399. And how many? 3. There are 3. And then less than 499. How many? There are 12. And this is 12. And here 27 and 50 and 61 and 66, right? So this is Ogive, percentage Ogive. Now, right now, using the graph, find the number of sales representative who have traveled less than 550 kilometers. Now we have to identify how many sales representatives who traveled less than 550 in the x-axis. In the x-axis, we find 550. Where is 550? Like here. 550, almost here. So this is point 550 and connect. Right, it's point here and this point. This point locate here. The starting 550 on the x-axis, draw vertical line and the cut at A, the corresponding to A, we get the P, right? It's 19. There are 19 sales representatives who have traveled less than 500 kilometers, right? And, right, if you want to find the percentile, right? If you want to find the percentile, what we have to do is, here in this axis, on the left hand side, we have cumulative frequency, cumulative frequency. In the right side, we can find the cumulative frequency percentage. How to calculate percentage? You see, at the zero, we put 0 percentage. And in the graph sheet, here 66, 66, the top, the total. The corresponding to the total, we put 100. And right, and then so this is 100 equal parts. If you use graph sheets, that's enough. If you want to find the percentile, or if you want to find the median, the mid value, this is what P50 is a median, no? P50 or Q2 is a median. Simply here, if we select P50, so these are the we convert into 100, no 100. So each point representing one percentile. So if we take 50 here, right? 50, this is 50 mean 50th percentile. If you want to find 67th percentile, you just find where 67 out of the scale hundreds. So there are two scales. On the left hand side, you can see the numbers, cumulative frequency. Here, cumulative frequency percentage. Here, my advice is to use graph sheet. You have to put only 2 points. Here 0 and 100. 100 at the top. 66. Then it's equally distributed. Equals parts. 100 equal parts. Right. Here what is P50 is a median. So this is a P here 50 and roll the line and bring the line here. This point representing the median. Right. Very easy. If you want to find the Q1 equal P25. Here we locate the P25 and then track the point, right? So this point representing the Q1 and Q3 equal P75. So we locate where is 75, somewhere here. So this will be, right? It will be 75. So in this way, we can calculate them very easily. I will give you exercise. Right. And the second, the number of sales representatives who have traveled more than 725. What's the question? The number of sales rep who have traveled more than 725. So here we find 725. Where is it? 700 and this is almost there. Here 725 at this point. How many employees? Bring this here. Oh, I think here. Okay, this is the point 725. This is 700 now almost. This is 725. And bring this point. How many? Right here. So up to this point, the employees who have traveled 725, less than 725. We know that there are 66 employees, and up to this point, it represents how many employees who have traveled up to this point. So the distance, this gap is what? The employees who traveled more than 725. So in that way also we can find the median of the distribution. Very easy. Here we see the 50 and P50, and then here this is the median. And 67th percentile of the distribution, so P67. Here 67 we point here, and then the cutting point here is P67. In this way we can find the answers. Right, here we come to summary. Histogram, right? Visual bars. Right? Histogram shows us a visual bars. Polygon is a line graph, so you can correct the point using a ruler. And a smooth curve, we can see the models. So, right, we can see the models. Now, Ogives like S curve, like this. Accumulation and percentage Ogive are in this side. Convert here percentages. I may give you one question. So this is a question. All right. So question. Everybody take the screenshot quickly. So do it by yourself. It's a practice question. Do it